Yes, am I audible?
Yes, sir. Good evening, sir.
Good evening, Arpit. So in the last class, we have finished Biot-Savart's law, the last application of Biot-Savart's law, which was magnetic field due to on the axis of a circular coil, right? We have finished that topic.
Yes, sir.
We have even started Ampere Circuit of Law, if not wrong.
Yes, sir. We just started.
Just started Ampere Circuit. Okay, let's recall Ampere Circuit of Law. See, Ampere Circuit of Law is more like Gauss law. We did Gauss law in when we were doing electrostatics. We did Gauss law. So Gauss law says if you have a closed surface, then electric flux passing through that closed surface is 1 by epsilon naught times the total charge enclosed by the surface. Now, just like Gauss law, you have this Ampere Circuit of Law. Just 1 second. Just like Gauss law, you have Ampere Circuit of Law. Instead of electric flux, Ampere Circuit of Law talks about line integral of magnetic field. So first of all, understand what do we mean by line integral. Line integral means, say you have a line, you take a line, this is some line L. Some magnetic field exists here, some magnetic field B exists here. So what you do is, you take a small line element dl, you want to take line integral of magnetic field over the entire wire. So you take a small length element dl, you take dot product of B and dl, magnetic field with this line element, and then you integrate it over the entire wire. This is what we call line integral. See, line integral is not a physical quantity. Force is a physical quantity. I can explain what is force. Magnetic field is a physical quantity. I can explain that space around a magnet is its magnetic field. Electric field is a physical quantity. I can explain space around a charge is its electric field. But line integral is not a physical quantity. Line integral is just a mathematical operation. It's like I ask you to add two magnetic fields. Addition of two magnetic field is a mathematical operator. I asked you to multiply two magnetic field. The multiplication of magnetic field is a mathematical operator. It's not a physical quantity. In the same way, this line integral here is a mathematical operator. It's not a physical quantity. What this mathematical operator says, it says take magnetic field, take dot product of magnetic field with a small length element, dot product, then it integrate it over the entire wire. This is line integral of magnetic field here. So Ampere Circuit Law says you have a wire. This is a current carrying wire carrying some current. This wire will definitely generate some magnetic field. So this is the magnetic field due to this particular wire. Around this wire, I chose a small element. Around this current carrying wire, I choose a element, circular element, a circular loop or something. See, no current is passing through this loop. There's nothing which is passing through this loop. I just choose a loop and I ask you to take line integral of magnetic field. So for line integral, what you will do, you will take dot product of magnetic field with the line element, which is B dot dl. Then you will choose a line element dl here. You take dot product here. Then you choose a line element here. Then you take a dot product here. Throughout the loop, you choose line element and then take its dot product with the magnetic field, means you get B dot dl. And you integrate it over the entire loop. So it's a closed loop, so I put a closed sign here. So that's closed integral of B dot dl. This is line integral of magnetic field. Ampere Circuit of Law says that line integral of this magnetic field is mu naught times the current I passing through the loop. So through the loop, this conductor is passing. The current through the conductor is I. So I can say that from this loop, some current I is passing. So you can say that line integral of magnetic field is mu naught times the current I passing through the loop. This is Ampere Circuit of Law. Line integral of magnetic field is over a closed loop is mu naught times the current I passing through the loop. There is one more concept here Okay, before this concepts, I just want to ask something. Akshay, the current is passing through the loop or from in the loop, or current is passing in the wire?
In the wire.
Current is passing through the wire, not in the loop. There is no current in the loop. Okay. Minashi, who is generating this magnetic field? Coil or wire?
Sir,
Sorry.
can you repeat the question?
Yes, I'm asking what is the source of this magnetic field? This magnetic field, huh? Who is generating this magnetic field? This wire is generating the magnetic field, or the closed loop is generating the magnetic field?
Wire?
Wire is generating magnetic field. When wire is passing through the loop. Hishma, here this DL that I am taking. What is DL here, Hishma? What do you understand by this DL?
It is a small element.
Of length, right?
Yeah.
Here we are taking DL as a vector or a scalar? Hishma again. Hishma, here this DL is a vector or a scalar?
Vector.
Vector. That means we are providing some direction to the length, which means we are providing a direction to the loop. So to provide direction to the loop, what we do, we use right hand thumb rule again. So what we do is, take your right hand. Now we are using right hand thumb rule to get the direction of loop. To give direction to this length, we are using right hand thumb rule. Do one thing. Take your right hand, place your thumb in the direction of current. Current is going upwards, so place your thumb in the upwards direction. Tell me about the curvature of your finger. The curvature of your finger is clockwise or it's anti-clockwise?
Anti-clockwise.
Anti-clockwise.
The curvature is anti-clockwise. Everyone is getting anti-clockwise? Noah,
Yes.
Ishika?
Yes.
Yes, sir.
Yes, you all are getting anti-clockwise. Huh? Where is Anshika? Anshika is not in class. Miraj?
Yes, sir, anti-clockwise only, sir, because it's up. And
Anti-clockwise. So this is how we decide the direction of the loop using right hand thumb rule. So just note it down, Ampere Circuit of Law. Then we will do one question and then we'll start some derivations on it.
Sir, we wrote it in the previous class.
You wrote it in the last class. Just write this expression. Direction of loop is given by right. Those who were absent in the last class can take the screenshot. We have already finished this topic in the last class. Just take the screenshot. Saifullah, you were absent for the last many classes. Where were you? Vacations?
I was on a trip, sir.
You were on the trip. Take screenshot, Saifullah. Just note down this direction, the rule for the direction of magnet.
Sir, can you show the first few lines?
Yes.
Yes, sir. Then.
Written this direction, this rule for the direction
1
of
minute, sir.
Anshika, we have just revised the Ampere Circuit of Law, huh? That we did in the last class. Just have revised this. Just write down the rule for the direction of loop. Just write down. This is the first topic here. Tell me once you all have written, we'll start some questions. Written?
Yes, sir.
It's okay. Now there's the next
Just a
numeric.
second, sir.
Yes. Yes, sir. Abid, this is x-axis. This is y-axis, huh?
Done.
Okay. And the z-axis is coming out of the plane of, if you are looking on the screen of a laptop, then this is coming out of the screen of the laptop. This is z-axis. Fine. Z-axis is out of the screen of your laptop. So if you take a mobile phone and you place your mobile phone in this way. So see now, that's your mobile phone. So this side is parallel to x-axis, Arpit, and this is parallel to y-axis. You can say that this is xy plane, okay?
Yes, sir.
Now look at this one. This one. Which one is this side, Arpit?
Sir, YZ
YZ plane. And which one is this one?
XZ.
That's it. So what's your confusion? You know it.
Yes. Sir, and like, how do we write that negative direction with the unit vector? Sir, that not happening.
Okay, that will come in the chapter again. We can discuss it again. Okay.
Okay. Sir.
So you're asking about the numericals, huh?
Yeah, yes.
That will come again in this chapter also. We'll discuss it. So this is one question. This is a loop of some arbitrary shape. Few currents are passing through the loop, I1, I2, I3. What does dot means here? Mehraj, what does dot mean here? This dot means. Mehraj Rahman.
Sir, the screen is not visible for me, sir.
Screen is not visible.
Yes, sir, I can't view the screen.
Just log out and then log in again.
Now it's visible, sir. Now it's visible.
Visible. Tell me, what does this dot means? This dot means inwards or outwards?
A point inside the field.
No. Dot means outwards, out of the plane of your screen. Cross means inwards, into the plane of your screen. So you have three currents. This current is cross, which means it's inwards, into the screen. This I2 is outwards, out of the screen. Similarly, this is also outwards. You have to calculate the line integral of magnetic field. See, so you have three currents. So choose any one of the current as positive. You have three currents which are acting in different directions, two different directions. So choose any one of them as positive. I consider this as positive. So if I consider outwards as positive, that means naturally my inwards would be negative. Now let's apply right hand thumb. Take your right hand, place your thumb in the outwards direction, in the direction of I3. Take your right hand, place your thumb in the outwards direction. And just tell me, where is the curvature of your finger? Is it clockwise or anti-clockwise? Anshika? The sense of the curvature of finger, is it clockwise or is it anti-clockwise?
Sir, clockwise.
Clockwise. Just take your right hand, put your thumb outwards, out of the screen of your laptop or your mobile.
Anti-clockwise.
It's going anti-clockwise, na? So the direction of the loop will be anti-clockwise. This is the direction. Nabil Khan, what if I place my thumb inwards? Then what would be the direction of loop? If I put my thumb in inverse direction, then what will be the direction of loop? Nabil Khan?
Clockwise.
Clockwise. Good. So now let's write Ampere Circuit of Law. Ampere Circuit of Law says B dot dl is mu naught I. And let's take one more current I4. Calculate line integral of magnetic field. Line integral, you can simply write this as closed integral of B dot dl is mu naught. We will take several curves. I1 is going inwards. We'll take it as positive or negative. We'll take it as negative. I2 is outwards. We'll take it as positive. I3 is outwards. Take it as positive. We will not consider I4 because I4 is not enclosed by the loop. I4 is outside the loop. So that is line integral of magnetic field, closed integral of B dot dl mu naught minus I1 plus I2 plus I3. This is Ampere Circuit of Law. Note it down. Tell me once you have written.
Answer.
It's okay. It's okay.
Sir, outward को हमने positive दिया.
That's your choice. Like basically, we take the direction which have greater magnitude of current as positive. So here I was having two currents in the outwards direction, so I consider outwards as positive. That's it. You have two currents outwards, one inwards. So I assume that outwards magnitude is greater than the inwards magnitude. So I take it as positive. So which one is greater? That will be positive. Now, to use Ampere Circuit of Law, we have to choose an Amperian loop. There's a certain criteria to choose Amperian loop. Does anyone remember what were the criteria to choose Gaussian loop? Gaussian surface, Noah, Unib. Noah, what were the criteria to choose a Gaussian surface in Gauss law? Yashika, what were the criteria to choose Gaussian surface in
There should be a closed surface.
yes, it should be a closed surface. Electric field should be uniform throughout the surface. Electric field should be parallel or perpendicular to the surface. Just like closed surface of Gauss law, Gaussian surface, in Ampere Circuit of Law, we choose Amperian loop. The criteria to choose Amperian loop are, the first criteria, your Amperian loop should be closed. Your electric field should be uniform throughout the Amperian loop. Your magnetic field should be parallel or perpendicular. These are the three criteria to choose an Amperian loop. First one, it is closed. Second, magnetic field is uniform. Third, magnetic field is parallel or perpendicular. So it should be closed, magnetic field should be uniform, magnetic should be tangential or perpendicular. Tangential means angle theta is 0 degree. Perpendicular means theta is 90 degree. And just remember, for a straight or cylindrical conductor, if whenever you have a straight conductor or a cylindrical conductor, your Amperian loop is always circular. So in 99.9% cases of Ampere Circuit of Law, we will always choose a circular loop. There will be only one case where we will be considering a square loop. Otherwise, we will always choose a circular loop. Note it down. Ampere Circuit of Law is a very small topic. We will try to finish it today. Very, very small topic. Okay, and Shika, I will share. It's okay. So can I scroll it if you have written?
1 minute.
Written?
Yes, sir.
Okay. Ampere circuit of law is a very scoring topic. You have 3 derivations, 1 proof and 2 derivations, and just 1 numerical on Ampere circuit of law. It's something very, very scoring. So the first is just the proof of Ampere circuit of law.
So that comes in the form of a question.
Yes, that can come in the form of a question.
Sir, can you show the last point of criteria to choose an Ampere's loop?
Yes. So if you have a straight or a cylindrical conductor, then your Amperian loop is always circular. So your circular loop will satisfy all these 3 conditions. It's closed, magnetic field is uniform, magnetic field is tangential or perpendicular. We will prove it, all these 3 criteria in this proof only. So you can get this proof, like prove Ampere circuit law. So we are not deriving Ampere circuit law. That derivation is not a part of school syllabus. You just have to prove it. So to prove Ampere circuit law, let's consider a long straight wire . A long straight wire and a circular loop of radius r. Circular Amperian loop radius r. So we take a long wire . Around this wire, I consider a loop. This is Amperian loop. The radius of the Amperian loop is r. Now let's calculate line integral of magnetic field. I need line integral of magnetic field. That is the step 1. First of all, we'll calculate line integral. What is line integral of magnetic field? This is closed integral of B dot dl. That's the line integral. Now, to solve this dot product, I need the direction of both current as well as magnetic field. For the direction of magnetic field, what we do is we use right hand thumb rule. We place the thumb in the direction of current, and this curvature of finger will give the direction of magnetic field. So the finger will curl in this way. So here the magnetic field will be inwards. This is the direction of magnetic field. Now let's consider the direction of loop also. For loop, we use the same rule. We place thumb in the direction of current. This curvature of finger will give the direction of loop also. This is the direction of loop also. So if I consider a small element dl here, see this loop is an exit plane. This loop is placed in this way. And this is the direction of loop. So if you take an element, the line element is going in this way, inwards. This is the loop. If you take a line element, it's going in this way, it's going inwards. So magnetic field is also inverse. This dl is also inverse. Now I have to open this dot product, B dot dl. Hishma, if B and dl both are inverse, then what is the angle between them? Hishma, if B and dl both are inverse, then what's the angle between them?
0.
0. So when you open this dot product, this is B dl cos 0. the dot product becomes its closed integral of BDL. Now, I need the expression of this magnetic field. Let's call this as equation number 1. Who is generating this magnetic field? A long straight wire is generating the magnetic field. What is the expression of magnetic field due to a long wire? Noah. Noah, what is the expression of magnetic field due to a long wire?
So mu naught 4 pi dl
No.
sin theta.
Nah. No. Miraj, what is the expression of Miraj is not in meeting. Akshay, expression of magnetic field due to a long wire. Array?
Sir, mu by 4 pi I into
Nah. Yashika, magnetic field due to a long wire.
Mu naught I by 2 pi r.
Mu naught I by 2 pi r. So let's substitute this value here. When you make this substitution, you will get its mu naught I divided by 2 pi r integral of dl. Now see, this mu naught I is constant. 2 pi r is constant. You can take all these constants outside the integrals. You are left with only dl. What is integral of dl? That's 2 pi r. So it's mu naught I divided by 2 pi r. Integral of dl is 2 pi r. So 2 pi r will cancel this 2 pi r and you will be left with mu naught I. Get proof now. This is the proof. B dot dl, and you get what is B dot dl? It's mu naught I. See, when we take this circular loop, all 3 criteria of Amperian loops are getting satisfied. The first one, when you take a circle, it's closed. See, magnetic field, this whole mu naught I by 2 pi r is constant. So it's uniform. I take it outside. Angle between B and dl is 0. So that means this criteria, tangential, this gets satisfied. So when you take a circular loop for a straight wire or a cylindrical wire, all your criteria gets automatically satisfied. Note it down. We'll do one numerical now.
सर अगर इसमें जो लूप का सेंटर है वो वायर पे लाई नहीं करता तो फिर ये रूल अप्लाई होता?
नो हम कोशिश यही करेंगे कि लूप का सेंटर, वायर को सेंटर लेकर लूप पे. We'll try to maintain the symmetry.
ओके सर.
Can I scroll it?
No, sir.
See, both dl and your wire, the magnetic field is in the inverse direction. Both are in inverse direction. Tell me if you have any doubt. Can I scroll it now?
Yes, sir.
Any doubt? Miraj? So Miraj. Arpit, any issue?
No, sir.
Saifullah, are you getting these things?
Yes, sir.
Did you went through the recordings of the last lectures, Saifullah?
Friday I missed, sir.
Friday. You missed. Nabil Khan, issues?
No, sir.
Miraj?
No, sir.
Alia?
Can you scroll up a bit?
Mm-hmm. This much?
Yes, sir.
Miraj, do something with your internet connection. Huh?
Yes, sir. So done.
Yes, can I scroll it?
Yes.
Yes, sir.
So let's do first question. No, we don't do this question. We will do this question. So you have a long cylindrical conductor of radius A. Calculate magnetic field due to this conductor at a separation. Start writing the questions. First R which is greater than A, then R which is less than A. And this is the cylindrical conductor. This is the cylindrical conductor. The radius of the cylindrical conductor is A, and some current I is passing through the conductor. Note down the question first. We'll finish Ampere Circuit of Law today. Just have this numerical and 2 derivations. That's it. So from the next class, we'll be starting Lorentz force. Written the question?
Yes, sir.
Okay. Okay, let's start. So this is the conductor. Some current I is passing through the conductor, and it's a long conductor. You're supposed to calculate magnetic field due to this conductor at R is greater than A. R is greater than A means point is here, outside the conductor. R is less than A means point is inside. First, we will be solving the first part. So point is here. So you take an Amperian loop outside the conductor, and the radius of the Amperian loop is R. So when we calculate using Ampere Circuit of Law, the step 1 is choose Amperian loop. So we consider a circular Amperian loop of radius R. We consider a circular Amperian loop of radius R, where this R is greater than A. So we consider a circular Amperian loop. Then what we did is we consider the line integral of magnetic field, step 2. Use Ampere Circuit of Law. Closed integral of B dot dl is mu naught I enclosed. That is the second step. Then in the third step, we will try to solve this integral B dot dl. Let's use all characteristics of the Amperian loop. If this is an Amperian loop, then what should be the angle between B and dl, Arpit?
0 degree.
0 degree. Saifullah, open this integral if the angle is 0 degree. How will you open this integral?
B into DL into cos theta.
Cos theta, and theta is 0. Then choose another condition. Then magnetic field is uniform. If magnetic field is uniform, then what simplification you can take? Miraj. Miraj, if B is uniform, then what should be the next step? Muhammad Adil. Who is Muhammad Adil? Yes, if it is uniform, then what simplification can you take? Hishma. Hishma, what should be the next step if B is uniform? I'm saying B is uniform.
You take the B out of integral.
Yes, we can take B out of the integral. So this is the integral of DL. What is integral of DL?
2 pi r.
2 pi r. So we have close integral of B dot DL as B to 2 pi r. That is my third equation. And the last and the most important step is to get the value of I enclosed. I need I enclosed. Only current is passing through the loop or through the wire?
Sir, wire.
Wire. So this is the loop, and current always pass through area of cross section. Current depends upon area of cross section. So how much is this area of cross section?
Sir, pi A square.
pi square. So this whole area is within the loop. So I can say that current enclosed by the loop is the total current passing through the wire. And how much is the total current passing through the wire is I. See, current does not depends upon the total area. Current depends upon the area of cross section only. So inside the loop, entire area is there. The whole area is in the loop. So you can say that I enclosed will be equal to the total current. I call this as equation number 4. You can substitute 3 and 4 into. So you can put 3 and 4 into. So when you put 3 and 4 into, you get B into 2 pi r is equal to mu naught I enclosed, which is I. So you can calculate B, which is mu naught I divided by 2 pi r. So this is magnetic field outside the conductor. It's mu naught I by 2 pi r. Is it clear? All steps? Ishma,
Yes.
Minashi, Akshay, any doubt?
So why did you take closed integral as is I?
Close integral, sorry.
The fourth step. Sir.
Fourth step. This one?
Yes, sir.
I take I enclosed equal to I. I enclosed is current within the loop. So if you take this loop, the whole conductor is passing through the loop, right? So I enclosed is the current passing through the entire conductor. And what is the current passing through the entire conductor? That is I.
Okay. Sir.
Okay, I enclosed. Let's take another example. Second part. In the second part is asking you to calculate magnetic field for R is less than A. What does R less than A means? The point is outside, yeah, point is inside.
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 Can you show the steps once
Yes.
more?
Yes. In the first step, we consider an Amperian loop of radius R, where R is greater than A. Then we wrote it as B dot dl as mu naught I. Then we wrote B integral of dl. Then we integrate dl and we get 2 pi r. Then we put I enclosed equal to I. Then we substitute the value of I enclosed as well as B dot dl in the first equation and we get the value of B. Mohammed Adil, is it your first class with me? Or you are? I don't remember this name in this batch. Mohammed Adil. Acha, okay, Umar, okay. So this is the magnetic field, mu naught I by 2 pi r. By the way, Umar, the timings of this batch is 8:30. We start at sharp at 8:30. Yeah? You can't benefit from this batch unless you come at time and you are regular in class. Otherwise, this batch will be of no use for you. B is mu naught I by 2 pi r. That's the magnetic field. Huh? Second part. R is less than A. You need magnetic field. Less than A means inside the conductor. So this is the conductor. This is the center of the conductor. This is the radius. R is less than A. That means your point is here. So what was the first step, Saifullah?
Consider a circular Ampere loop of
And where,
radius.
oh, sorry, the radius of the cylinder was not R, the radius of the cylinder is. So the Amperian loop will be inside the cylinder or outside the cylinder, Saifullah?
Inside.
Inside. So this is the Amperian loop. Huh? This is the Amperian. What is the radius of the Amperian loop? It's R. So let's start the calculation. Step 1. What is step 1, Nabil Khan? Nabil Khan, step 1. Nabil. Nabil Ahmed, what was the first step?
Against draw Gaussian, draw Amperian loop.
Consider an Amperian loop of radius r. And now r is less than it. Nabil Khan, you're not in class, na? Step 2. And remember, r is less than it. What was the second step, Akshay?
Closed integral of b dot dl equal to
Mu
mu
naught I.
0 into I enclosed.
That's the second step. What is the third step, Noah?
So we will open the closed integral, that is b dl cos theta.
Yeah, when you solve this b dot dl, see, this is the standard calculation. Every time this comes out to be b into 2 pi r. This is always b into 2 pi r. So I'm writing it as b into 2 pi r only. That's third step. Hishma, what is the fourth step?
To calculate the current.
Current. Hishma, now tell me, what do you think? I enclosed, the current passing through the whole conductor is I. And this is your Amperian loop. So current enclosed by the Amperian loop is still equal to I. It's greater than I. It's less than I. What do you think?
It will be less than.
Less than I. Very good. Everyone is getting this. See, the I current is passing through the whole area. But I'm not considering the whole area. I'm taking a small element of radius R. So I enclosed is not I enclosed is less than I. Now the major issue is in these type of numericals, the major issue is always this I enclosed. How to calculate this I enclosed? To calculate this I enclosed, let's do one thing. Let's use unitary method. What is the radius of the conductor, Uni?
A.
What is the area of cross section?
Sir, pi,
Sorry.
sir, pi square.
And current passes through area of cross section. That means current passing through this pi a square area is I. I current is passing through this pi a square area. So current passing through unit area. How much current will pass through unit area? Only
Sir, I upon pi.
we have to calculate I enclosed. Anshika is not here. Arpit, I enclosed is passing through which area?
Yes.
Sorry,
So can you repeat it?
I'm asking I enclosed is passing through which area? The total area of cross section of conductor is pi square. Huh? So
Yes,
through
sir.
pi square, I current is passing through unit area. I by pi square is passing. I'm just asking, what is the area of the Amperian loop? Area of Amperian loop. The radius is R. Arpit. कहाँ गया? Arpit, I can't hear you properly. Say it again. Area. Amperian loop, radius R. What's the area? Nabil Khan. Area of Amperian loop.
2 pi r.
Area is 2 pi r or circumference is 2 pi r?
Higher.
Pi r square.
Pi r square.
So you need current passing through area pi r square. We need current through the Amperian loop. Now the radius of the Amperian loop is r, area is pi r square. So we need a current through pi r square. What will you do to calculate current through this pi r square? We'll multiply it with pi r square. C pi cancelled. So I get I enclosed is equal
R square by.
I into R square by A square. So we get I enclosed here. So what we can do is we can just substitute all values. We can substitute the value of B dot DL, which is B into 2 pi R. We can substitute the value of I enclosed. So let's substitute 3 and this thing 4 in, again, equation number 2. So when we substitute 3 and 4 into, we get B dot dl, which is B into 2 pi r, is mu naught I enclosed, which is mu naught I r square by a square. So this r will cancel this square, and you get B is equal to, we get B is equal to mu naught I by 2 pi a square. This is the expression of magnetic field, mu naught I by 2 pi a square. And this is 1 r in the numerator here. So that means B is directly proportional to R. Inside B is directly proportional to R, and outside your B is inversely proportional to R. So what is the shape of the graph? If I draw the graph outside the conductor, what will be the shape of the graph, Minashi?
Parabola.
Not parabola. See, we get parabola if B is proportional to R square. But if it's proportional to R square, then you will get parabola. It's inversely proportional. What is the shape of the graph, Miraj?
Will be linear.
No. Saifullah?
D is
It's not linear. Linear means R should be in numerator. Saifullah, what will be the shape of this graph? Hyperbola. Hyperbola means this one. You increase one, another term will decrease. And what is the shape of the graph here, Nabil Khan? B and R are directly proportional. What will be the shape of the graph? Which one?
this one will be linear.
This will be linear. This is linear. Nabil Khan, what will be the shape of the graph for this equation?
Shape of the graph.
Yes, what will be the shape of the graph? Straight line, parabola, hyperbola, circle.
Linear, right?
Linear is the equation. Shape. What shape of the graph you will have?
Straight line.
Curved.
Straight, straight line. Okay, I'm revising you just for those who don't know how to plot a graph if the equation is given. Okay, at the end of this, I will do. Just note this question. At the end of this question, I'll explain how to decide the shape of the graph using equations. Note it down. And please don't just copy this numerical. Try to do those calculations on your own. Nabil Khan, doubt in any step?
No, sir.
But write down. Do it.
So this is the second part, right?
Sorry?
So this is the second part of the question, right?
This is the first part of the question.
Sir, but
Sorry.
sir, in the starting, sir, we
R is greater than A. We are taking the point outside. Miraj, you were saying something. Your issue got clear?
Can I scroll it now? Nabil Khan, you have written up to here, no?
Yes, sir.
You want me to scroll up? Nabil?
1 second. Sir.
Yashika, any doubt in the calculation?
Yes, sir. You can scroll.
So,
Yes.
where can you explain the fourth step?
Sorry, repeat which one?
Sir, can you explain the fourth step again?
See, in the fourth step, you just need the current passing through the Ampere loop. So current is basically passing through the conductor, and whole of the conductor is enclosed by the loop, right?
Yes,
Loop
sir.
is outside the conductor. So the current enclosed by the loop is the current passing through the conductor. And the current passing through the conductor is I. That's why I wrote I enclosed equal to I.
Okay, sir. Got it.
Can I scroll it?
Yes, sir.
Nabil Ahmed, an issue?
Sir, in the fourth step, is it I enclosed is less than I?
Yes. Why? Yes, Nabil. You want to ask why? Why enclosed
Yes,
less than I?
Yes, sir.
See, Nabil. The current passes through the area of cross section. The complete radius of the conductor is A. The area of cross section of the conductor is pi A square. But so the current I is passing through this whole area of cross section, this whole, this whole. Current I is passing through this area. But when we take an Amperian loop, we take an Amperian loop is inside it. So this is the Amperian loop. Now check, Nabil.
Sir,
Just 1 second. Just 1 second. So this is your loop. So can this loop enclose the entire conductor?
No, sir.
So can current passing through this loop be equal to I? Because I current is passing through the entire conductor. So the current passing through this one will be I, or it will be less than I?
Less than I, sir.
I is passing through the whole thing. Oh, this is less than I. Yes, Arpit, you're asking something. Arpit,
sir, I forgot.
you forgot. Alia, doubts?
Yes, sir. Yes, sir. Sir, I was asking like in this case, sir, the Ampere, this loop was smaller than this. So, sir, I enclosed it in smaller. But, sir, in the first case, sir, it was like, why didn't we take it as greater than I enclosed?
So current is passing through the free space or current is passing through the conductor only?
Sir, it's conductor.
So there is no current here. No? There's no material here, no current here. That's why. Right?
Yes, sir.
Yes, everyone have written? Nabil, Akshay, Yashika, Noah.
Yes, sir.
Okay. Now, in the next part, you're supposed to plot magnetic field versus position graph. So those who don't know how to plot a graph, see. So to plot a graph, you need following things. See, if equation is linear, means x to the power 1 and y to the power means. This means your graph is a straight line. This is x, this is y, the graph will be a straight line. If your equation is quadratic, y to the power 1, x to the power 2, that's quadratic. Then your graph is a parabola. This is x, this is y, this is parabola. This is one is parabolic shape. We use half parabola. Full parabola is this, but we use half parabola. So this will be the shape of the equation. But if y goes as 1 by x, or it goes as 1 by x square, or it goes as 1 by x cube, in all these questions, these are inverse relations. Shape is hyperbola. Hyperbola means this shape. This is x, this is y. This shape is hyperbola. You increase x, your y will decrease. Now let's plot b versus x graph for this equation. B versus x graph of this equation. This is R and this is B. So what is the shape of the graph? So let's divide this into parts. Here your R is 0. R0 means center.
Sir, can you go up?
Yes, just 1 second. R equal to capital R is surface. Just 1 second. R is less than R is inside. And R is greater than capital R is outside. Yes. Yes. You want to ask something? So you have to plot B versus R graph. So this is the inside region. Inside, see your magnetic field inside is proportional to R. So Nabil Khan, what will be the shape of the graph if B is proportional to R? Straight line, parabola, hyperbola.
A straight line.
Straight line. So inside the graph will be a straight line. When you go outside, see after surface, that's outside region. Outside your magnetic field varies as 1 by R. So Nabil Khan, what will be the shape of the graph?
Hyperbola.
Hyperbola, great. So it goes straight, it increases, then it decreases. So B inside is directly proportional to R. B outside is inversely proportional to R. So these are the shapes of the graph. Do it. Okay, right from here. Okay. So written. See, the next topic is solenoid. Huh? See what is solenoid. Everyone has written the last numerical, na?
Yes, sir.
Yes, sir.
See what is solenoid. This is a typical solenoid. A solenoid consists of number of turns of a wire. You take a number of turns of a wire and you pass current through it. It generates magnetic field. These are magnetic field lines of the solenoid. So it consists of number of turns of insulated copper wire. Here in this particular diagram, you can see that these wires are wound over nothing. Means the core of the solenoid is here. You can have any medium as core. Here in this particular question, I take core as the air. So I take wires, I take number of turns on air. So that's the core of the solenoid. Core is here, but usually we consider iron as a core. The reason is iron is a ferromagnetic material. Permeability of iron is very, very high. So when you use iron, the magnetic field increases. It becomes 1,000 times. Like if you take the same system, you wound this wire over air, let's say you get 1 Tesla of magnetic field. But if you wound the same wire over iron frame, soft iron core, something, the magnetic field becomes 1,000 Tesla. Iron is used as a core to increase magnetic field. Let's do some approximations for a long solenoid. For approximations for a long solenoid is, okay, this is solenoid. Using Ampere Circuit of Law, we will derive a long solenoid. Long solenoid means whatever calculations we will do it for a long solenoid. So let's see what does long solenoid means. Long solenoid means length is very, very greater than the radius. So for a long solenoid, length of the solenoid is very, very large as compared to the radius of the solenoid. That's a long solenoid. The next are approximations for a long solenoid. See, if you have a solenoid and that solenoid is long, like if you have a long solenoid, then you can use certain approximations. The first approximation is that magnetic field outside the solenoid is negligible. You can look at the field lines also. See, inside the solenoid, field lines are very close. That means field is very, very strong. But when you go outside the solenoid, see the field lines are very smaller number of field lines. Means the magnetic field is very, very weak. So we can say that as compared to inside, when you go outside, the magnetic field is almost negligible. So magnetic field outside the solenoid is negligible as compared to inside. Second approximation, if you look at this central region, I'm not sure, central region is not very visible, but still if you look at the central region, the region from here to here, you can see that field lines are straight. See, these field lines will curve at the ends, but in the central region, field lines are pretty straight. These straight field lines means field is uniform. So the benefit of using a long solenoid is the first, magnetic field outside the solenoid is negligible. Magnetic field in the central region is uniform. These are the two benefits, or you can say two approximations for choosing a long solenoid. Note it down, then we will derive the magnetic field using the solenoid. We'll start the calculations.
So here, what is the first point written?
Okay.
Number of turns G.
Sorry.
Sir, what it is written, sir? Number of turns G.
Of insulated copper. Sorry. Number of tons of insulated copper. हाँ जी, written.
1 minute. Done, sir.
Okay, the time is almost over. We'll start this calculation in the next class. So next class, this is just two calculations are there. One is solenoid and another is toroid. And and then we'll start the force on a charged particle. So we'll stop magnetics here and we will start the revision of current electricity.
So can you show the approximations for long solenoid?
Yes, yes, yes. Yes, written, Nabil?
Yes, sir.
Okay, we'll start the calculation in the next class. Huh? So let's start the revision of current we were doing. Huh? So we have discussed these circuits and okay. No, we have discussed this circuit now. So in the last class, the circuits that we have discussed were mostly based on series and parallel combination of cells and resistors. Now the circuits that we will do now will be based on, mostly we'll be using Kirchhoff law today. Mostly Kirchhoff law. So let's start with this simple problem of 2020, the first question. You will do this question, do it first. So you have two cells, huh? Sorry, what is this? Wait. This is something missing. Don't do this. Something missing, something fishy here. Do this question. You have two cells, current is given, you just need potential between B and A. Just open your notes, go to the topic where I have started that Kirchhoff law, go to the first numerical of Kirchhoff law, you will be able to solve this question. It's 9:57, I will wait for 3 minutes and after 3 minutes I'll start the calculations. Simple, very simple application of Kirchhoff law. And I think the way this question is given, you don't even need to solve the equations. We have given you current. You can decide current in each branch. Potential at B with respect to A means we need VB minus V. 58, 2 more minutes left. Answers? The easy question, yeah. Okay. Omar got -1. What about the rest? The simple calculation. Got an answer from Noha, from Arpit. Okay. Just 1 more minute. Okay, time over. So I got answers from Minashi, Nabil Ahmed, Arpit, and Noah. Arpit and Noah are correct. Others are making some small mistake. Let's do it, huh? See, you have to calculate potential difference between B and A. Potential difference between B and A means VB minus VA you want. So you can go from B to A through any path. This resistance is not given, so we will not go through this path. We will go through this path. Noah, what is the current through this 2 ohm resistor? Noah. Your answer is correct. What is the current through this 2 ohm resistor? See, this is 2 ampere current. Huh? The 2 ampere current is here. The 2 ampere comes here. Then your 2 ampere divides into two parts. 1 ampere goes here, and then 1 ampere goes here. 1 ampere goes up to here. 1 ampere is coming from here. Then they will combine and form 2 amperes. So the current passing through this 2 ohm is 1 ampere. So we'll be choosing this path. We will choose path PDCA. We will go from B to D, so that's VB. Lower to higher, it's rise, so +2. Then you'll go from D to A, you're going in the direction of current, it's -2 into 1. Then you'll go from C to A, high to low, it's fall, -1. Minus VB is equal to, sorry, minus VA is equal to 0. So +2 minus 2 will cancel. You will get VB minus VA is equal to 1 volt. So the correct answer is 1. I believe the numerical that we did in the class, this is third or fourth part of the numerical. Is it clear now? Minashi, Akshay,
Yes, sir.
Nabil, clear now?
Sir, can you explain again?
Sir, why didn't we go from the 1 volt? Why didn't we go upwards?
Why we?
So from the 1 volt cell, we moved right. Why didn't we go upwards from there onto the 2 ohm resistor?
2 ohm resistor. See, the current, the direction of current you are saying, or
Yes,
the
yes,
movement you are saying?
yes, the direction of current.
Direction. See, here it's 2 ampere of current, right? So when this 2 ampere divides into two parts, 1 ampere goes here, you know that 1 ampere is going here. So another 1 ampere will go downwards only. If it go up, then 1 and 1 will cancel out. Na? Then you will get 0 here. If you draw it like this, you say 1 ampere is going here, 1 ampere is going here, and 2 ampere is coming from here. Then 1 and 2 will combine to give 3, but it's not 3, it's 1 ampere. Your junction law will break.
Yes.
सर वैसे अगर ऑप्शन एलिमिनेट करना है तो फिर नेगेटिव वाला एलिमिनेट कर सकते हैं ना?
No, just by looking at the circuit, you can't decide whether the voltage is positive or not, positive or negative.
सर क्योंकि अगर पॉजिटिव होगा तो हाई पोटेंशियल से लो पोटेंशियल मूव करेगा तो फिर पॉजिटिव ही आएगा ना?
The movement is our choice now. We are moving from B to A. It's not this. There's nothing mentioned in the question that you have to move from B to A. The direction of motion is our choice. You can move from B to or A to B. Just by looking at the circuit, you can never decide whether which one is at higher potential or which one is at lower potential. But yes, in this particular question, you can say since current is going from B to A, so B should be at higher potential and A should be at lower potential. That logic can work. Okay, Unif? The logic that current is going from B to A, that can work. Yes, if current is going from B to A, that means B should be at higher and A should be at lower. Otherwise, just by the direction of our movement, you can't decide. The movement is by choice. I can choose from A to B or B to A. Anyways, Cephala, you did Kirchhoff law with us?
Yes.
Okay. So we are moving from B to A. Huh? We first go from B to D. When we go from B to D, it's a lower terminal than the higher terminal. It's rise. So we wrote this as +2. Okay. Then
No, how did you get VB and VA?
Okay, the point B, I wrote the potential of B point will have some potential, so I name it as VB. And the last point is always when we are going from one point to another, then we assume that our initial point is at higher potential and lower point, final point is at lower potential. That's why I write it as VB and write this as minus of B.
Yes, clear, sir.
Oh yeah, this is a very easy problem. Just do this question number 3 fast and don't make any mistakes. A very easy problem. See, this symbol means the wires are crossing over. There's no connection here. This wire is crossing from above this wire, first wire. So AC and BD are not connected. Wire AC is going over this wire BD. There is no connection here. This is the symbol. This says these two wires are not connected. It's going from above this wire. Simple problem. It should not take more than 10-20 seconds. Just look at this question, it gets solved. No, Umar, it's the wrong answer. Very easy question. No, Umar, it's again a wrong answer. Umar, this guesswork doesn't work in physics. You have 4 options. If there is negative marking, then the probability of getting a right option is not even 25%. It's less than 5% because it's a negative marking here.
Sir, is that I1 next to 4 ohm?
I1, yeah, it's I, the current I. This one?
No,
Yes,
sir,
this is
that
I1.
one.
I1. Yeah, that's I1. That's I1. Right. That's I1. This is what you have to calculate. Answers, Yashika, Akshay. Good, Akshay. Okay, time over. See, this 4M and 4M are in series, na? See, this 4M and 4M are in series, and from the ends of A and C, you have this cell. So the voltage drop across 4M and 4M is 8 volt. You don't have to worry about the entire circuit. Don't worry about these resistors. They're not affecting your circuit. Just take these two. Huh? This one, 4 ohm, 4 ohm, cell, 8 volt. That's it. R equivalent is 8 ohm. Voltage is 8. So I is 8 by 8. It's 1 amp. C bar. Is it clear, everyone?
Yes, sir.
Simple questions based on NCERT concepts. So, what is this question? Okay, let's do this question number 4 also. Just write down this language, then I will come to the circle. Just note it down, then I will come to the circle. See, for the last 2-3 lectures, we have not studied any single concept which was not in NCERT. And from this year onwards, maybe your JEE and NEET exam gets mixed with CUET. Mixing JEE and NEET with CUET means the paper will entirely depend on NCERT. Depend on NCERT means the theory part will be from NCERT, but yes, they can modify the numerical separately. There are very high chances that from this year onwards, your JEE and NEET get mixed with CUET.
सर तो जेई का जो एनसीईआरटी के बाहर वाला सिलेबस होता है वो आएगा या नहीं?
करते हैं यार हम, लेकिन एग्जैक्ट पता नहीं, कम चांसेस होंगे अभी भी। ये तुम अगर 2020, 22, 21 देखो, So बहुत कम questions हैं उन concept पर which are not in NCERT. But yes, what जो कुछ भी NCERT में उसे tough कर देता है because it's JEE, कुछ ना कुछ तो करेगा वहाँ. But theory ऐसी नहीं है कि ना हो. Previous years workout करो clear हो जाता है उसे. Okay, note down this question and tell me what's the correct answer. Ideal voltmeter reads 1.5 volt. That means voltage across the system is 1.5 volt, nothing else. Everyone have written the question? Nabil, Akshay.
Yes, sir.
Yes, sir.
Answers. Voltmeter reads something. Nah, the question says voltmeter reads 2 volt across the 10 ohm resistance. That simply means voltage across this 10 ohm resistance is 2 volt. And what you're supposed to calculate, you're supposed to calculate the internal resistance of cell. You have two cells of internal resistance R and R. Straightforward formula based thing. Answers. Nabil, Ahmed. If you want to know the pattern of any exams, go through the previous year's questions. Just solve last 5-year questions. You will know what's the pattern, what's the syllabus. No answers, huh?
Sir, one minute, sir.
Akshay got something. Okay, Akshay, let me check if you are correct. And a simple question, huh? Good, Akshay. Yes, Akshay is correct. Minashi, any answer? Sorry,
Doing.
you're doing. तो स्कूल में कोई बहुत टीचर ढंग का पेपर बनाना चाहे ना, he can put these questions. You can't say that these are not in your syllabus. I'll wait for 1 more minute, then I'll start solving. See, 1.5, 1.5. Nabil Ahmed. No, Nabil, it's again a wrong answer. See, 1.5 and 1.5 are in series. So 1.5, 1.5 means this 3 volt. Yes, Minashi, you are correct. Internal resistance R and R means internal resistance is 2R. The voltage drop across this 10 ohm is 2 volt, which means the voltage drop across this 15 ohm is also 2 volt, which means the voltage drop across the combination this is 2 volt. This we know. Now let's take combination of 15 and 10. What is the parallel combination of 15 and 10? 15 into 10 by 15 plus 10. So that's 150 by 25. What is 150 by 25? That's 6. So you have 6 ohm resistor. Then you have a 2 ohm resistor. Then you have a cell of 3 volt and internal resistance 2R. And this is the current through it. The current. This is the current. So let's calculate the things here. So you know that voltage drop across this 6 ohm is 2 volt. Across this is 2 volt, across this will be 2 volt because they are in parallel. So across the combination will also be 2 volt. Let's say this current is I. So the voltage drop across 6 volt is 6 into I, which is equal to 2 volt. How to calculate this I? I is voltage, which is 3, total resistance, which is 6 plus 2, 8, plus total internal resistance, which is 2R, and this is equal to 2. So you get this equation. From this equation, you can say 18 by 8 plus 2R is equal to 2. So you have 18 is 16 plus 2R. When you take it to the left hand side, you get 2 is equal to, no, not 2R, sorry, 4R. 2 equal to 4R. You get R equal to 2 by 4. 2 by 4 means half ohm. So half ohm means option number B. Write down the solution. Do this, question number 5.
Sir, can you explain again?
Yes. See, the voltage across the 6 ohm, see, the voltage across the 10 ohm is 2 volt. 10 ohm and 15 ohm are in parallel. So the voltage across 10 ohm and 15 ohm both is 2 volt. Or I can say that voltage across the combination is 2 volt. So first of all, I'll take equivalent resistance of 15 and 10, which is 15 into 10 by 15 plus 10, that's 6. Okay. Now,
Okay, sir.
1.5 and 1.5 are in series, so that's 3 volt. R internal resistance series, it will be 2R. Say some current I is flowing through the circuit. What is I? If I is flowing through the circuit, then voltage drop across 6 ohm is 6 into I, which is 2 volt. Then how to calculate I? I is total EMF by total external resistance plus total internal resistance. EMF is 3 volt. Total external is 6 and 2 are in series, so it's 8. Total internal is 2R, which is equal. Is it clear? No?
Yes, sir.
Okay. Good. Solve this fifth one. Do it. We have some time now. We can do 5th and 6th question. Fast, 4 minutes.
Should we do the 5th one, sir?
Yes, 5th one. You have to solve these equations using Kirchhoff. It's a bit lengthy problem. You get 2 equations, 2 variables. Are you solving it? Muneeb? Nabil?
Sir, can we use Wheatstone bridge here?
No, 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 no. See, when you use Wheatstone bridge, then you have a single cell only. Okay. Whenever you have multiple cells, that means it's not a Wheatstone bridge. In fact, when you have multiple cells, always prefer Kirchhoff law. Although using some trick, I can solve it using the parallel combination of cell also, but it's better if you use Kirchhoff law. So make a thumb rule. Whenever you have more than one cell, use Kirchhoff. Although there is a trick for this numerical using parallel combination of cells also, but solve it using Kirchhoff law. Okay, let's solve it together. It will take time. See, the simple application of Kirchhoff law. You can start from any cell. I start from this cell. I say the current is I1, I1, I1 here. I1 goes out of the cell, so I1 current should enter. Then I say that this current get divided into 2 parts. One is I2 here. I2 goes here. Then the remaining is I1 minus I2. This goes here, this goes here, this goes here. It's I1 minus I2. So I2 is going in the downwards direction. I1 minus I2 is going here. Just combine them and you will get the I1 again. So you just have to get the value of I2. If you have I2, you can calculate potential difference between A and B. So let's write the equations for this loop and this loop. For this loop, the direction is given, so we can write the equations easily.
Sir, but in E2, the current will move upwards, right?
That arrow is insignificant. Huh? You don't know the exact direction of current, Nabil. When we use Kirchhoff law, we assume the direction. I don't know whether the current is going downwards or upwards. My answer will tell. If my I2 comes out to be positive, that means yes, my direction is right. If I2 comes out to be negative, that would mean the direction that I have considered is wrong. The actual direction is the reverse of it. Got it? You got it, Nabil.
Yes, sir.
So from lower to higher, E1. And how much is E1? E1 is 2 volt plus 2. You're going in the direction of current, it's I1, R1. R1 is 1, so it's minus I1. When you're going downwards, in the direction of current, it's minus I2. How much is R2? R2 is 2. Then you're going from high to low. High to low means fall, minus 4. Then you're going to the left, I2, I1, R1. R1 is 1 minus I1 is equal to 0. So you have minus 2I1 minus 2I2 minus 2 is equal to 0. You can take minus 2 as common. So when you take minus 2 common, you get I1 plus I2 plus 2 is equal to 0. So you get this equation that I1 plus I2 is equal to minus 2. That's my first equation. Let's move in this loop. When we go from here to here, R1 is 1. The current is I1 minus I2. Minus of I1 minus I2. Then you go from here to where? Higher to lower, it's fall. E3 is minus 4. Then again, you are going in the direction of current. R1 is 1. The current is I1 minus I2. Minus of I1 minus I2. Then you are going here, lower to higher, rise, plus E2. E2 is 4. Then again, you are going in a direction opposite to that of current. The current is I2, resistance is R2 plus I2. R2 is 2, so 2I2 is equal to 0. So this is minus 4, will cancel this plus 4. It's minus I1 plus I2 minus I1 plus I2 plus 2I2 is equal to 0. Minus I1 is minus 2I1. I2, I2, I2. 4I2 is equal to 0. So what we can do is we can just take this minus 2 as common. You have I1 minus 2, I2 is equal to 0. So you have I1 minus 2I2 is equal to 0. That is second equation. And you have I1 plus I2 is equal to minus 2. So when you add these equations, it's minus 1, it's minus, will cancel out, minus 3, I2 is equal to minus 2. So you get I2 is 2 by 3. Once you have I2, you can calculate the potential difference. You need VA minus VB. So VA minus VB is, you're going in the direction of current. So it's R2, I2, R2 is 2, I2 is 2 by 3. So minus 2 into 2 by 3. Then higher to lower, it's fall. E2 is 4. So this is whatever you get from this is VA minus V. Note it down. Simple application of Kirchhoff law, nothing else. This is again based on the first example that we did in Kirchhoff law. The first example of Kirchhoff law.
Sir, I1 plus I2 will be minus 1, right?
I1 plus I2 will be minus 1, you are saying.
No, the first equation.
Yeah, sorry. your I2 will be 1 volt.
सर पहली वाली इक्वेशन में जो पहला वाला स्टेप है उसमें I1 की जगह माइनस I2 नहीं होना चाहिए था लास्ट में.
Yeah,
Yes.
it's I1. Here it's I1. The current is I1. I2 is up to this thing. This is I2, then this arrow is I1.
सर आपने I2 लिखा हुआ है ना इसके साथ.
मैंने इस वाले arrow के लिए लिखा है, इस वाले. इस arrow के लिए.
तो सर मतलब वो जो दूसरे
I1.
से करंट आ रहा है उससे कंबाइन होकर I1.
हाँ.
How did you get 1/3?
This is minus 2 I2 and this is minus I2, right? So it will be minus 3 I2 and this is minus 1, 0 minus 1. Yes, written.
Yes.
Okay, so we'll stop here. You can just check the value of VA minus VB.
सर वो जो सेकंड लूप में जो फर्स्ट वाला स्टेप है उसके लास्ट में 2I2 क्यों है?
ये है ना R2. It's 2 ohm current passing through this is I2. Okay, so let's stop here. So circuits from my side, circuits are over. From next in the next class, we will do one more type of circuit.